Okay, today we are going over 12.2 conditional probability. So let's take a look at what conditional probability is first. So conditional probability contains a condition that may limit the sample space for an event. So it's putting a certain condition on the probability. So here's going to be the notation, and that is read as the probability of event B given event A. Probability of event B given event A. Okay, so finding conditional probability. So this is one of the problems we did in class, and we filled out a class survey here, so I'm going to just go ahead and make up the numbers since we don't have a class here. So we'll say that we're looking at a table that shows the results of a class that have a pet. So the number of males that have a pet, we'll just say that there are 7 males that have a pet, and we'll say there are 3 males that do not have a pet. And then we could say that there are 12 females that have a pet, and there are 8 females that do not have a pet. So we're going to find the probability that someone has a pet given they are a male. So this condition limits the sample space. It's not talking about everyone here. So one of the ways we can do this is we can actually look at how many people have a pet, and is the key word here, and they are male. And then we can divide that by the probability that they are male, whatever the given part is, given that they are male. So we can find the probability that they have a pet and they are male. So they have a pet and they are male. That's 7 out of their total of, this is 10, another 20, so that's out of 30. That's the probability of them having a pet and they're male. And then we'll divide that by the probability that they are a male. So there are 10 males in this class. So 10 divided by the total amount, which is 30. So we know that when we are dividing by a fraction, we always multiply by the reciprocal here. So I have 7 over 30. Instead of dividing here, I'm going to multiply, and then I'm going to take the reciprocal of 10 over 30, which is 30 over 10. And then we can see that the 30s will cancel out, and we get a 7 over 10, which is 0.7 or 70%. Okay, the other way we could have done this is we could have looked at this as an easier way. If you notice here, the denominators for these are both always going to be the same. They're always going to be the same because if you're looking at the probability, you're looking at everything overall. So what you can do instead is you could just drop the denominators right away. This is actually called a complex fraction. And we learned that if you have a complex fraction and if the denominators are the same, you just drop the denominators. So instead here, we can just say the probability that they have a pet given they are male. We're going to look at where is it both. The probability that they're males and they have a pet is 7, divided by the number of males. So this part here, the given part, is always going to be our denominator. Okay, so then we count how many males there were that took the survey. 7 plus 3 is a 10, which is 70% of what we had earlier here. So that's kind of the faster way to do this. You can do it this way as long as you understand how to do it this longer way with the probabilities. Moving on. Okay, so let's take a look at another example here. We are looking at the waste collection in the U.S. and the first one we want to look at is the probability that it is paper given it is recycled. So again, we're going to look at where is it both paper and recycled. Here it is, 34.9. 34.9, that'll be in our numerator then. Divide that by, so we're going to look at, okay, the recycled is what's actually in the denominator here. So I'm going to actually add up everything that is recycled. So I'm going to add these all up. 34.9 plus 6.5 plus 2.9 plus 1.1 plus 15.3. That's in our denominator because it's all of the recycled. So that goes in the denominator. So we're going to have 34.9. When I add all of this up in the denominator, I get a 60.7. And then we can divide that, and we're going to get that to be about 0.57. So that's about 0.57 or 57%, which means that the probability of paper, given it was recycled, is 57%. All right, so here is our formula for conditional probability. The probability of A cannot be 0 because obviously we cannot divide anything by 0. So here's our formula. The probability of B given A will be equal to the probability of A and B divided by the probability of A. We did that earlier, but here's the formula. Good thing to have down. Later on, we're going to have to use this formula and manipulate it a little bit, because now we will know that if we need to find, say, for example, the probability of A and B, we can do that by just manipulating this formula a little bit. So what I can do here is, if I want to find what is the probability of A and B, let's say we know the probability of A, we know the probability of B given A, and we need to find the probability of A and B. So we can get that by itself. We're going to multiply both sides by whatever the probability of A is. That will cancel this part out. And the probability of A and B will be the probability of A times the probability of B given A. And we're going to look at that later on. We're going to have to know that. Okay, so moving on here. This is just another example, so we'll move on here. All right, so we're looking at a student in Buffalo, New York, made the observations below. So of all snowfalls, 5% are heavy, meaning it has to be at least 6 inches. Okay, after a heavy snowfall, schools are closed 67% of the time. After a light snowfall, meaning less than 6 inches, schools are closed 3% of the time. So we want to find a few things here. We need to find the probability that the snowfall is light and the schools are open. We also want to find the probability that schools are open given a heavy snowfall. So we're going to start off by saying, all right, either it is a heavy snowfall or it's a light snowfall, right? So out of all snowfalls, 5% are heavy. So this is 5% or 0.05. So if this is 0.05, which was given to us, then the light snowfalls would be 0.95. It has to add up to 100% or 1 as a decimal. Okay, after a heavy snowfall, so after we take this route, it was a heavy snowfall, there are 2 different options here. Schools are going to be closed 67% of the time. So schools are either closed or schools are open. So schools are going to be closed after a heavy snowfall. So given that it was a heavy snowfall, it's going to be closed 0.67 or 67% of the time, which means they are open. 1 minus that will give us 0.33 or 33% of the time. Okay, moving on here. Now we're going to look at if it was a light snowfall. Again, we're going to have 2 different options. So we'll have either schools are going to be closed or open. So after a light snowfall, schools are closed 3% of the time. So either it's closed or open. Sorry, this is a C here. So schools are closed 3% of the time, meaning if it was a light snowfall, so after a light snowfall. So this is 0.03, and it will be open 0.05%. 0.97, right? 1 minus 0.03 is 0.97. So now we have to look at, okay, we're going to find the probability schools are open given it's a heavy snowfall. So this right here, this first option is saying this is the probability schools are closed given it was a heavy snowfall. And that's going to be 0.67. 0.67, 67% of the time. Okay, this one here is the probability school is open given a heavy snowfall, and that is 0.33 or 33% of the time, and that's what this was asking. This is saying the probability school is open given a heavy snowfall. So we just found that one right here. It is 33% of the time. We just found that with our tree diagram here, so this is 33% of the time. Okay, moving on here. So this is the probability school is closed given a light snowfall. And this is the probability school is open given a light snowfall. All right. So now the last thing we need to find is the probability that the snowfall is light and the schools are open. So here's our keyword, and notice in this one it was a given. So we now need to look at, we're looking at, okay, we know we're dealing with open and light. So from our previous formula, we know that the probability of the school being open, given it is a light snowfall, will be, this is a given, not an I like oil, but open given light, okay, will be the probability of it being open and a light snowfall divided by the probability. The given part is always your denominator here, so the probability it was light. This is what we want to find, the probability that the snowfall is light and the schools are open. So open and a light snowfall. So this guy right here up top. So we're going to actually solve for that. So the probability it was open given it was light, we have that right here. That's 0.97. 0.97 is equal to the probability of open and a light snowfall over the probability it was a light snowfall. We have that one right here is 0.95, and then we're going to multiply both sides by 0.95. 0.95. There we go. These will cancel, and therefore the probability it is open and light will be about, when we multiply 0.95 times 0.97, we're going to get about 0.92 or 92% of the time. And that covers 12.2 conditional probability. Thanks for listening.